Okay, we are going to, this is basically for you to check your work and make sure you're doing it okay. And if you have any questions, then obviously I'm not here, so then you can look at this as you need to. So you don't have to technically, I guess, go in order or even watch the whole thing. It's just so you can be like, oh, let me see if I got this one right. So you can jump through the video, or if there's one that you really want to be like, let me see how she's doing it, you can stop and watch the video for that too. What I don't want you doing is just copying down your answers, because then that's not going to help you, because you're going to have a worksheet after this that's going to be for a grade, and I don't have a video for that one. So just kind of make sure that you're doing the right thing, which you guys are normally really good about that anyway. So 8.3 and 8.4. 8.3 is all limiting reactants. So it's which one of my reactants, which is on the left side of the equation, is stopping my reaction? Which one is limiting how much product I can make? So we're always looking at product. And then 8.4 is percent yield. So we'll look at like the percent yields. So for instance, number 1, it says iron 3 oxide, which is this Fe2O3, reacts with carbon monoxide, which is the CO, to produce, so here's my products, iron and carbon dioxide. Now it's already, balanced for you. It wants to know what is the percent yield for the reaction if 65 grams of iron oxide produces 15 grams of iron. So here's the problem. I need to figure out which one did I actually produce. So that's why I always ask, what did I actually make? And it says produces 15 grams. So there's my actual. So I know that the percent yield is actual over theoretical. So I got my number that goes on top. So I need to figure out, okay, in theory, what should I have made? Because remember, like very rarely do we make 100% of what we are. If I were to bake cookies, or even the s'mores pops for that matter, we had chocolate that was like dried around the edges. We did not use all that chocolate. So we didn't produce maybe as many s'mores pops as we could have. Same thing with chocolate when you're making chocolate chip cookies or any kind of cookies. Do you eat some of that dough? If you ate any of that dough, you did not produce 100%. So here we go. I'm going to take this number, then the 65, to see what should I have made. If I made all 100%, what should I have made? So I'm going to 65 grams of Fe2O3. Now, I've got to get to grams of iron. Okay, that's my actual. My actual is 15 grams of iron. So the bottom needs to be in iron. So I'm going to try to get to grams of iron. So I know gram to gram, right? That's going to be a 3-step problem. I've got to go grams to moles, then I've got to go moles to moles to switch over to iron, then I've got to get how many grams of iron. Okay, now Fe2O3, if you look up there at your periodic table, that is 160 grams in 1 mole. Now I'm at my mole to mole, so I'm going to put moles of Fe2O3 on bottom, and I want to get to iron. Now anytime I do a mole to mole, I'm using my equation. So Fe2O3, there's 1, iron is 2. Then my last step, I'm going to do moles of iron and grams of iron. Now, grams of iron rounds up to 56 grams in 1 mole. So this is 45.5. So if I wanted to produce 100%, I should have produced 45.5 grams of iron. I actually only did 15, so that's not great. So I'm going to put this number right here. All right, this is step 1. Step 1 is doing the conversion. This is step 2. So 15 divided by 45.5 equals 0.32967, blah, blah, blah. So I'm going to move this decimal point 3 spots over. So you could tell me 33%. I know I tend to keep some decimals. I'm not picky. You guys know I'm not picky on this. Either one of these. Or, yeah, 33, 33.97. If you want to keep more decimals, that's fine. I'm not picky on that. All right, on B. What is the percent yield for the reaction if 75 grams produces 15 grams? This is what I am actually producing. So that means I'm going to take this number to do the conversion. So 75 grams, and this is a carbon dioxide, right? That's what I'm trying to get to. So 75 grams of CO. I'm going to do a three-step problem to get to grams of carbon dioxide. Now I know this is grams, so grams of CO, that is 28 in 1 mole. So my moles of carbon monoxide go on bottom. I'm going to try to get to CO2. Use your equation, 3 moles of CO, and then there's 3 moles of CO2. So then moles of CO2 down here, grams of CO2 here, and that is 44 using my periodic table over 1. So now when I take 75 divided by 28, these cancel out already. And multiply by 44, that is going to give me, gosh, 117.857. Once again, you may have rounded differently than me, and that's fine. So that's step 1. Step 2 is now doing percent yield equals actual over theoretical. So my actual was 15. I'm going to divide by 117. Man, this one's bad too. If you're trying to get 100%, it's not going well here. Now to get percent, I would multiply by 100, or like I did before in the previous, just move your decimal 2 spots over. So this would give you about 12.7% as your percent yield. Not a great number. All right. Number 2, look at this. It says propane, which is C3H8, burns in oxygen. Now, oxygen is a gas, all right? It's a gas in normal circumstances. So there we go. To produce carbon dioxide, 2 oxygens, plus water. All right, now when I go to balance this, I'm going to do my hydrogens first. There'd be a 4 there. That's good. As long as it's an even number, I'm good. I'm going to put a 3 here to balance my carbons. Then I'll do my oxygens. So I have 6 oxygens there, 4. I've got 10 oxygens. So that's going to be a 5. Now, it wants to know what is the percent yield for CO2. It's 81 grams produces. There's my actual. And then it also lets me know which product I'm going to be using, the CO2. So let's take the 81 grams of C3H8, do a 3-step problem to get 2 grams of CO2. All right, C3H8, that is 44 grams if you look at your periodic table and use it in 1 mole. Okay, so I'm going to put, these cancel out, I'm going to put my moles, C3H8, and I want to get to CO2. Use your equation, so 3 and 1, right? 3 and 1. That cancels out. I'm going to have moles of CO2 down here, and grams of CO2. CO2 weighs 44 grams in 1 mole. So 81 divided by 44 times 3 times 44, that is going to give you 243 grams of CO2. That is step 1. Step 2 is now doing your division. Taking that 135 divided by 243 times 100. So this would be like 0.55556. You can multiply that by 100 or just move that decimal. So this would be 56%. Or you could say 55.6%, however you want to round it. All right, let's flip over to the back. For each of the following reactions, calculate the moles of indicated product produced when 2 moles of each reactant is used. So I'm telling you, hey, if I have 2 moles of SO2 and 2 moles of O2, how much product is it going to make? Okay, so, and for this one, let me write down here. So if I have 2 moles, yeah, and it wants moles. So I don't have to go to grams. I was just making sure I have to do a 3-step problem or anything. These are going to be 1-steppers. So 2 moles of SO2, 2 moles of O2. Do 1-step problems here. So moles of SO2, moles of SO3 on top. That's what I want to end with. Moles of O2, moles of SO3 on top. So use your equation. For instance, up here, SO2 is 2, SO3 is 2, O2 is 1, 2. So this would just be 2 moles. So should be 4 moles. All right, so here's the thing. It wants to know how much is produced. Well, your answer is going to be that. Because what happens is you're going to make 2 moles of SO3, and then you're going to run out of sulfur dioxide. And you will run out of sulfur dioxide, so you will never have enough to make that 4 moles. You will make 2, and then you are done. And you've ran out of one of your reactants. All right, number 4 is the same way. If I have 2 moles of iron, I have 2 moles of water. All right, so here it tells you, I put this because kids really struggled. I didn't used to say find iron oxide, and they would be like, I don't know which one to do. The thing is it doesn't matter. You could do iron oxide or you could do hydrogen gas. As long as, if I decide I'm going to do hydrogen gas for this one, I'm going to find hydrogen gas for that one. But kids were really struggling, so I just put find iron oxide. So let's do that. So I've got moles of iron, moles of the FeO, and this is 2 and 1. Let's do the same thing here. I've got 4 moles of water. I'm getting all these from my equation. 1 mole of FeO. All right, so this one would be 1 mole. And this one, when I take 2 divided by 4, is going to be 0.5. So I make a half of a mole, and then I run out of water. And if I run out of water, my reaction stops. All right, number 5, let's do 2 moles of each reactant. What is that, 16, I believe? And then 2 moles of O2. All right, so moles, C7H17. Same thing with this. I just went ahead and put CO2 on here. Okay, use your equation. This is 1, CO2 is 7, oxygen is 11, and CO2 is 7. So this would be 2 times 7 is 14. 2 times 7 is 14. 14 divided by 11 is 1.3. I would make 1.3 moles of CO2, and then I would run out of oxygen, and my reaction would stop. So I never get a chance to make 14 moles because I've run out of one of my reactants. It's like me being like, I want to make a batch of cookies, but I only have, I don't know, a half a cup of flour. Like, I'm not going to make a whole batch of cookies. I'm going to run out of flour. All right, let's do this bottom one here. Doing the exact same thing. So we're using 20 grams of each, and it's still a calculate number of moles. So this one's going to be a two-stepper because I'm starting with grams and I need to get to moles. So let's do 20 grams of aluminum, 20 grams of chlorine. All right, so aluminum is 20 grams, right? I'm looking at my periodic table for that. And then moles of aluminum, moles of aluminum chloride. Using my mole to mole, I'm using my equation. Oh, no, sorry, that should not be a 2, or 3, that should be a 2. Okay, my chlorine. Now, I use 35.5 when I do my chlorine, so I'm getting 71 grams here. If you didn't do 35.5, if you rounded, your answer is going to be a little bit different than mine, which is fine. So now I do my mole to mole, moles of chlorine, moles of aluminum chloride. Use my equation. Chlorine is 3, aluminum chloride is 2. So I'm going to take 20 divided by 27, and these two cancel out, so that's going to give me 0.74. And then over here, 20 divided by 71 times 2 divided by 3. I'm putting moles, or grams, I'm sorry guys, this is moles. Shoot. And this one's 0.19 moles. That is how much I make. I'm making the least amount because once I make 0.19 moles, my chlorine runs out and my reaction stops. All right, let's look at number 7. I've got 20 grams of my ammonia. I've got 20 grams of my oxygen. That's going to be 17 grams. Using my periodic table. finding water. Once again, we didn't have to find water. I could have found NO if I wanted to. So 20 divided by 17. Oh, I got to do my moles here. NH3 is 4, H2O is 6. So this one would be 20 divided by 17 times 6 divided by 4. Okay, now let's do my oxygen. This is going to be 32 grams. Remember, it is O2, not just O. Now let's see here. I've got 5 moles. I'm using my equation now for my mole to mole. So 20 divided by 32 times 6 divided by 5, 0.75 moles of water. So my answer is 0.75. Or if I were to ask you a different type of question, which one's the limiting reactant, it would be oxygen. But they asked how much is made. 0.75 moles is made, and then the reaction stops. All right, let's do this last one. 20 grams of carbon disulfide and 20 grams of oxygen. All right, we're going to find the sulfur dioxide. So let's hear. CS2 is 76 grams and 1 mole. All right, now my mole to mole step, I'm going to use my equation to get these numbers, and there's 1 mole of CS2, and there are 2 moles of SO2. So I'm going to take 20 divided by 76 times 2. That gives me 0.53 moles of SO2. All right, now this one, oxygen, remember it is O2, so it is 32 grams and 1 mole. Now using this equation, we've got 3 moles of O2 for every 2 moles of SO2. So 20 divided by 32 times 2 divided by 3 is 0.42 moles of SO2. All right, so this is how much I would make, and then my reaction would quit, and it would be done. All right, so you have some math. That is today's worksheet. You have one that is for a grade that obviously I'm not giving you guys any, any videos on. So I am going to let the sub know to let you check your equations. If there's any equations you have to do like we did right here on number 2, I want her to let you check and make sure that you have done that correctly. So try it though, try to do it, and then check with the sub on the answer key. All right? Okay, guys, that is it then. I hope you are doing okay, and I will see you soon. Bye.